Alrighty, let's prepare for day 15 of Advent of Code, coming up in 30 seconds. Day 15. There's goblins that are trying to steal the perfect cocoa. We have a map of things. And it's going to be a combat simulation. Okay. This is going to be fun. Each unit that is still alive takes a turn, reserving all of its actions before the next unit's turn begins. On each unit's turn, it turns to move into range of an enemy if it isn't already, and then attack if it's enraged. All units are very disciplined and always follow very strict combat rules. Units never move or attack diagonally, as doing so would be dishonorable. Hence why queens apparently do it. Oh wait, that's not a good idea. Okay, when multiple choices are equally valid, ties are broken in reading order, top to bottom, left to right. For instance, the order in which units take their turns within a round is the reading order of their starting positions in that round, regardless of the type of unit or whether other units have moved after the round started. This is already sounding really similar to the one we just had with the carts. Or we're going to have to predefine the order, and then we process them in that order. Each unit begins its turn by identifying all possible targets. If no targets remain, combat ends. Then the unit identifies all the open squares that are in range of each target. These are the squares which are adjacent to any target and which aren't already occupied by a wall or another unit. Alternatively, the unit might already be in range of a target. If the unit is not already in range of a target, there's no open squares which are in range of a target, the unit ends its turn. If the unit is already in range of a target, it does not move, but it continues its turn with an attack. Otherwise, since it's not in range of a target, it moves. Good grief. So we got complex board game AI mechanics going on here. First considers the squares that are in range and determines which of those squares it can reach in the fewest steps. A step is a single movement to any adjacent open square. Units cannot move into walls or other units. The unit does this while considering the current position of units. Does not do any prediction about where units will be later. Multiple squares are in range and tied. Step which is first in a reading order is chosen. Each of the goblins is open. Good grief, this is going to be complex to implement. This is day 15. How long is this thing? Oh my goodness! Holy crap! I'm not gonna be able to finish this all in one go, I think. Holy cow! And I hate implementing Pathfinder algorithms from scratch. They get kind of old. Okay. So everything, like if there's ambiguity, you choose the one that's first in reading order, which means we're going to be doing a lot of calculations that involve heavy ambiguity, or having to keep track of all possible options and then deciding whether there's a reasonable one. Once they reach the positions above, range of a target, cannot find any square in range of a target. Similarly, attacking, it'll attack the one with the fewest hit points. And again, ties are broken with the first in reading order. I mean, it deals damage equal to its attack power. Each unit has 3 attack power and starts with 200 hit points. You need to determine the outcome of the battle, the number of full rounds that were completed, multiplied by the sum of the hit points of all remaining units at the moment combat ends. Wow. Wow, there's a lot of complexity going on here, so we're gonna have to break this down at least. Let's grab our input. Oh my goodness. Look at that cave. Isn't it beautiful? Oh boy. Oh, it even makes a beautiful little map on Emacs. Just lovely. Absolutely lovely. Okay, let's take a look at our starting map. Okay, looks good to me. Let's see. Let's go ahead and define some helpers here. A wall is something that looks like, well, that. The space looks like that. And this will probably be a little cheaper if we do. Okay. Similarly, a space is oops. And then elf. Okay. Next step. We'll need a way to keep track of all of our units. Let's see here. Let's go ahead and say, Goblin. Ah, my goblin, sure. We got a goblin. We've got HP 200 according to the problem statement. Okay, we got there we go. I think that'll do. Okay, and then we have, what do we call it? Let's see. It's going to be the quickest way to handle this. Thinking of a few things at once here. Let's go ahead and start with this. Okay, let's go ahead and say The initial units of a map are for each X for each Y in the number of rows in the map, and for each X the number of columns in the map. So for each Y combination, let's go ahead and call one of these units then we can say when unit no let give me a second. We're gonna let map item be get in map YX. When unit map item, then we're gonna get map item to unit map item. So if I get the initial units of our map right here, he don't like it. He don't like it one bit. Oh, I gotta be careful with my naming here. What do they call it? Dungeon. How's that sound? Yeah, I'm doing this probably about the slowest way I could possibly manage. It's not initial dungeon, it's starting dungeon. I should probably be more consistent terms. Didn't like something in here. Oh, right. Okay, you know, you gotta actually use this correctly. Range of count of dungeon. Range of count of first dungeon. There we go. That's our grid mechanics. Still doesn't like that. I gotta actually give it an X and Y. $22 1 2 3 4 5 looks good. Okay. That seems reasonable. So that gives us all of our units. Okay, what's next? Def blank dungeon is the result of map being So for each element here, if X is a unit, then space, otherwise X. So this will give us an empty space that we will drop things into, I think. It's gotta be. There's gonna be some things I'm missing here. But for now. Yeah, because this will give us basically a map that we can drop all our items onto at once. Okay. Let's go ahead and run this. Didn't like that. I gotta actually apply it to something. Let's just take the inth, which is going to be called an index. That didn't work. Ah, right. I'm gonna map this against all the elements of starting dungeons. There we go. That looks better. Unit construction. Frankly, this, we'll see. It might end up being simpler to model in object-oriented terms, but we'll stick with Clojure for now. Let me think here. The main reason that we need to identify all the units strongly up front let's see. This is going to be a real long one. Okay. We need to gather them all up front because we have to keep track of their individual health. So that means each of these has an identity we care about. I could give them IDs or something, but the problem is I'd have no way to map from a given G on the board back to that health value. So I at least need to know what my initial units are up front once and for all, and then I'll just track them by their coordinates thereafter. So let's just try something here. Place units, and we got a set of units, and we're going to drop them on an empty map. SOC in our %1, our map. This is going to seem, well, reverse the position of our unit. So we have to look it up in YX order. That's just the nature of how we've done this. Now that I think about it, I might just transpose this so it's in column major order. No, that'll make later iteration hard. Okay, we'll just do this for now. But we do probably want to have another function that'll wrap this logic up because we're going to use this a lot. So units to look up. Let's call it that for now. This is just going to be reverse the position of the unit. Okay, and that makes us into more verbose, but also clearer. So in that empty map, or in that current map that we have, we're going to get that position of that unit, and we're going to drop in try this instead. Type C. That simplifies that a little bit. It's not going to like this last one, I think. Okay, there we go. So we got a unit to look up. We're going to associate that with the type of our unit that we're iterating over. We're going to hand it an empty map to start with, and that'll get filled in. And then we're going to iterate over all of our units. So if I int of place units, initial units of our starting dungeon, onto our blank dungeon, doesn't like. And look at that, our goblin's right back where we had him at the beginning. Great. So that lets us take things off the board, put them on the board over and over. And we'll want that because it'll make our pathfinding algorithms a little easier, I hope, later on. If we can have them around to block the path, basically. Let's see. So we place solar units on a map. What's our next step? We need to teach, I think, how to pathfind, or let's go. They give you a hint by giving you a step-by-step how they come to their conclusions. So we gather which squares are in range. We need to first figure out for a given unit see. Dungeon manipulation. I could split this into multiple files at some point, but for now, one long file it is. Unit. Let's add another thing up here. Solid X or unit X. Wall X. So that'll let us find out quickly whether a given space can be crossed or not. And we'll definitely need that for the pathfinding as well. Okay. Unit logic. The enemies of a unit in a list of units. First, we actually want to know logic. Okay. Whoa, I can't spell. 2 units are enemies. If the type of unit A is not equal to the type of unit B. Filter so that gives me all the units that are enemies of this one enemy. So for the goblins, it should return all elves. For all elves, it should return all goblins. Let's go ahead and try this out by saying the initial units in our starting dungeon. Let's grab the first one in that, which is going to be that goblin up there. And we're going to just recalculate this real quick. Should be cheap. And we can see it brought us back a list of elves. Great. So that's perfect. That's exactly what we want. So we have identified all the targets. Let's see, we want to know open squares. Is that what they call? They just call it in range. So the squares in range of a unit on a map are those squares let's go ahead, save. Supporting data. Messing with coordinates. Let's just say cardinals of, that's probably a good name, of an X and a Y. Are Inc X Y, Dec X Y, X Inc Y, oops, and X Dec Y. And that should give us the 4 squares on each side of a given unit. Now determine which items are in range on the given map. So let possible spaces be the cardinals of the position of a unit. There we go. So those are our possible spaces. This whole X, Y, Y, X flip is going to keep hitting me, isn't it? I really should just be storing these in, like, index order inside of the units. As long as I don't forget. Which, watch this. I'm just going to forget sometime in this. It's going to screw everything up for hours. Okay. I don't see any other place where I'm using Y or X yet. So I think we're okay. Maybe that'll make me remember. Probably not. Okay, we got our possible spaces again. Let's go ahead and just represent this with the 4. I think this is actually going to be much neater. For possible space in the cardinals of that position, let the get and map possible space when the item is solid. Actually, here we go. We need something is a solid only if it's not a space. So that's actually, this is a better representation for that, I think. Okay. When the item is a space, then we're going to give back the possible space. So let's just say what's in range for the first of our what is in range for our initial units in the starting dungeon given the starting dungeon map. Only 22.6. What's the first in there? It should be 22.7 or 23.6. 22.5? I need to... $5.21, and we know this is $5.22. $5.22. Okay, that's good. So that gives us that the only open space next to this goblin is this space right here. I think I'm okay with leaving it there for now. So that's our in range query. Reachable is a little harder because you basically have to do a depth first search over the whole thing, or not depth first even. It just has to be a search. Whew. Okay. Filter reachable. reachable chords on a map. So we're going to just do this using a loop, I think. It's just going to be simplest here. So our current scene is nothing. So for this given unit, oops, aiming for these destination chords on this map, so we start with an empty set for the things you've seen. Okay. That was not going to be a sneeze after all. Let's go ahead and let our starting chords be the in-range coordinates for our unit. Scene is going to be a set of our starting chords. We're going to let our cue be our starting chords. I'm not too worried about optimizing this for now. A list of starting chords. Here we go. So you have a... let's swap these two real quick. I like those definitions in reverse for some reason. There's something else here I'm missing, I think. No, I think that's it. Ah, no. I'm going to implement a couple variants of this, and I probably could compact them down. One of them is going to require calculating distance. This one's just calculating reachability. This is like a first pass with very, very dumb logic. because the other one's going to want to use a breadth first search. This one's just using any old search. Okay, we'll see what this is for now. We've got the stack, we've got the things we've seen. And we're going to go ahead and say let the next chord I'm going to take the popped item off the stack. Oops. And we're going to go ahead and say add the popped item to the things we've seen. Oops. New scene is this. And we're going to say popped adjacent will be no. Will be those things that are in range of popped. And I think we're going to want our set functions here. We're going to want a lot of those, I think. So we're going to get we've just looked at a new cell. Let's say we were over here. We just looked at the cell, we added it to the list of things we've seen, and we go ahead and we say, we're going to add the adjacent items on the list as long as we haven't seen them yet. Okay. I'm going to need to try something here. Let popped and rest of empty. I think it should just be nil. Nil, nil. Okay. If the stack is empty, we're going to short circuit this whole deal. And we're going to say intersection of set of discords and our scene items. So basically, hey, if there's nothing left on the stack, there's nothing else we can observe, we're going to stop processing, and we're going to just find all the coordinates that we have seen. Otherwise, we're going to Just going to process the next thing on the list. Conj into rest stack opt adjacent. In recur with our new stack and our new seed. So let's find out what these two are here. Should be O. So 7-11 should be not accessible. But 9-11 should be. From our goblin's perspective over here. Start dungeon. That's our unit, our destination coordinates that we're aiming for, and our starting dungeon. Here's hoping this works. Did not like it. Wrong number of args to in range. In range needs to take in our map. Sorry. Dungeon, not map. Okay. No value supplied for key 521. That's that guy over here. A persistent hash map create. In range. Oh, okay. Oh, in range is only checking for a... Okay, that's why. That seems more reasonable, I think. Consistent vector cannot be cast to javelin number. Am I misunderstanding how destructuring works here? Why is it passing in a vector here? When it cannot be cast to Java line number. I do think it's something to do with my destructuring here, but I'm not sure what it is. Unless I'm passing in something bad here. Popped is just a coordinate. YX. Let's look up Clojure destructuring syntax. Should be able to use that. I guess I don't need YX anymore, so I don't know why I'm doing this. Let's go ahead and clear that out and change it for pause. Still don't like it. This is getting kind of silly, but it's a list containing 521. So, something I'm putting on that list isn't working as intended. And that is also, I think, well, no, it's the first chord I find. So what am I doing here? Into a list containing 1, 2, and 3. Push 1, 1. That's what I expect to see. a new stack, and a new list of seen things. Stack's not empty. Otherwise, let the popped items and the rest of the stack. The stack. Oh, set difference is probably doing something weird. Let's see how it behaves if I handed a set of things. Still behaves the same, basically. Okay, let's try this. In range. It's about like this guy again. What's this give back? A list of vectors, correct. Let's try this. Let X and Y be 1 in X and Y. Come on. 1 and nil. And if I do into nil 1, 2, 3, that's just going to give back the list. Oh, it actually works. What if I gave it something like this? Still should behave. Still behaving. Okay, now I'm a little befuddled about what's going on over here. Okay, let's just go ahead and this is where you start having to do some guesswork to figure out what in the world's going on. Whoops. So it's not even getting to that point the first time. It's the very first run that it's failing on. Okay, what's our starting chords look like? That a stack that contains 521 first. And now it's grabbing 521. Okay, that might be my hint actually, right here. It's not grabbing the entire list. So something about my destructuring isn't working then for the stack itself. Oh, you know what it is? Oh, I've done this before. Crap. When you want to create a new list, or you want to turn something into a list, you can't use the list method. Okay. I've done this before too, and it always gets me eventually. You basically have to do apply list. Okay, we're closer now. Turn the in-range things into a set. There we go. Now 911's the only one we can reach. Okay. Great. That took way too long. Give us a little more room to see what's going on here. I think we're okay with that. Alrighty. That took way too long to figure out what was going on there. But that does now give us all the reachable spaces from a given coordinate. Now, we're going to look for okay, now we have to do the fun one, which is finding the nearest one. If we did the previous one with a Q instead of a stack, we get a breadth first search. And we can not only find which coordinates are accessible, but which ones are accessible at which range. So let's try something slightly different here. Let's go ahead and make this a separate one. From an initial position, see. This is going to do a loop where our Q is applying a vector to our starting core. Scene set. Just realized that's a bit of a malfunction there. We want to see. We want to use a queue instead of a stack. We're going to keep track of our distances. The trick in my mind is that there's got to be a better way to figure out what the distances are, and especially in my initial state. I don't really have a good way to say, hey, I haven't seen anything yet, but I happen to know what distance they already are. Try that. So basically each item is going to come in as a coordinate and the current distance from the location. Then we're going to look at the number of items we've seen. That's just still going to keep track of stuff that we don't continue looping in on ourselves. That's just going to be coordinates only. Distances. There's an empty map. Do I need that? Yes. So the maximum distance I've seen is 0. This can help us say, hey, if our max distance ticks up by 1 since the last one we've seen, and we have found any of our coordinates, we're done. Like, we can stop right there instead of having to search for everything. That's going to help us keep that second pass much shorter. I'll start there, and we'll see if we need to add anything later. So, if our queue is empty, desk distances, that's the distances we need to keep track of. Okay. Just gonna grab the keys. A tag for myself to resolve the ambiguity later, which they said it has to be resolved in reading order, left to right, up and down. So if our queue is empty, we're going to go ahead and just hand back all the keys that we've seen. That's likely going to happen if all of our destinations are equally far away. So basically, if we have an empty queue or we've already found all of our destinations, then we're done. Otherwise, we're going to basically do something very similar to what we already had. We're going to go ahead and say it's not going to be pop, sorry, this is going to be there we go. So that's the new elements that we've seen already. This is very similar stuff here. This is just all about generating new elements to add to our queue. Oops. Make sure I have good closure on these. Okay, I think we're good. So now we're going to have to do a couple of extra things though. So we now know how to make the next item in our queue, the next items in our queue appear. We now need to check to see if popped is anything we've seen before. Or, well, not if it's anything we've seen before, if it's one of our destination chords. If if the distance is greater than the max distance, so we ticked up, and our destination distance is not empty, so aka if we found any of our things, this is what I just talked about. If we already found something, and now we're looking for things that are farther away, clearly farther away, then we're going to go ahead and also return our keys at distances right here. I wonder if I can do this. So if any of these conditions hold true, then we're returning this. This and go. I think you can do that with loops. I'm really hoping we can. So that gets rid of that thing. So now we still need to figure out how to say new max distance is max of distance and max distance. That's easy. Ta-da. Okay. New dest distance. If so if our destination chords contains the current one we're looking at, then we're going to go ahead and say associate with in dest distances. Just pull up a vocab. Done. Otherwise, we're just going to return the same dest distances we already had. And we're going to recur with the new queue, new scene, new max distance, and destination distances. And it actually accepted it. Oh no. The nearest from... What was this again? 522. So the nearest from 522 of this set of coordinates $14.21. I'm going to try one close-ish. 1427. There we go. And one way over here. 1411. In our starting dungeon. Okay, it dies again. It does not like our zip map up here. I'm probably not understanding how zip map works. Oh, right. Repeat one. It's not supported on long. Which means I'm passing something funny in here. Oh, I see what it is. Okay, so this is key here. We don't just have popped adjacent here. We have map chord into chord ink distance. That's a key miss, okay, but easy to catch. Okay, we got nil here. You bailed early. So it is running for a long time. In fact, it looks like it's running all the way to the end. However, I'm noticing that I'm using a queue, not a list. See that? It's breaking some assumptions in my algorithm. Very fussy. Okay. Yeah, doesn't like it. So where's this going wrong? Why am I getting a list instead of a vector here? Is it because of the destructuring? It probably is because of the structuring. It's been skipping a lot tonight. Weird. Yeah, the destructuring is destroying it. But if I do... Okay. Well, for now, I'm just going to do a conversion, and we'll see if that ends up being too costly. So, into vectorized rest queue, toss this. Did I just make myself an infinite loop? I think I made myself an infinite loop. I definitely made myself an infinite loop somewhere. Okay. Let's go ahead. There it is. You see it? I do wish there was an easier way to say break out of current processing function, but I still don't know of one for Cider. Okay. Didn't like something. I have things defined in the wrong order here. Ah, there we go. See that? Interestingly enough, it's giving me back basically equal. But that's also a really slow running time for this, which makes me worried that each turn is going to take excruciatingly long. Let's count this out here. One, two, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I'm not convinced that it's giving me the nearest one there. It's also found a way. Oh, it did find a way in. Hold on. 1, 2, 3, 4. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Oh, yeah, that's right. Okay, that... So actually, that tells me it's working right. That's funny. I didn't even plan on that. So now we actually need a function that disambiguates when given a choice between two locations. No good. Whoops. The first of sorting by reverse. So... Actually, I think it's just sort by. Okay, if I get rid of this guy, who's next? 1027. So it takes the highest row and then the furthest, the lowest X, yeah. So if I get rid of this one, I should get 1421. That works. Okay. Hoo boy! Okay, so that's our nearest one. Ready? And this is where, honestly, it's just better to build a graph, because now look, we have to recalculate which one will take you closer. So normally what you do here is you give each cell a predecessor it points to that tells you where it came from. Whew. Okay. And this is the other tricky thing, as I said, if you have a choice between predecessors, pick the one that is also the first in the reading order. Dagnabbit. This is going to be really a pain with the mutability, I think. Again, like, you can do these kinds of things in functional. It could just be a little more of a pain to shuffle memory around like this. Or I'm trying to do too much in one function, which is also a possibility, because this thing is a monster. Look at this. Look at the size of this. This is a... like a 30-line monster. Okay. This is all standard, like, Dijkstra stuff. So let's come up with a special function here. The weird thing here is that I could, under theory, get something. I can get to a point where I'm traversing this graph, where the graph is all the empty spaces here in this dungeon. And I can get to a point where I reach a node from one path, and then I reach it from another path, and I say, actually, these are the same distance away, and I want this one to override this one. I could probably do that with some sort of priority map, honestly. So instead of just pulling items off a queue, I'm now pulling items off of a heap where order is not only determined by distance, but also secondarily by what its origin node is. So where I'm starting from next to my goblin here. Because then I can trace it back to that predecessor and say, hey, this is the one to step to. Is there a persistent heap sitting around for me to use? Priority? This could be useful. The other issue here is that none of this is like contextless. I need a collection that uses a specific comparator when I'm applying priority map. And this may be part of the interesting issue here, is that because collections can't, well, they can, it's not as trivial to create a collection that has a custom comparator that it holds to. That said, that would just be like another field on the collection, so. Is there any way here to provide a custom comparator? Yeah, I'm not sure if there's going to be a better way to do this than to brute force it for now, but that's going to make it take even longer, and that worries me. Well, I know I've been streaming these pretty much non-stop, but I might have to return to this one later, mostly because I have brothers waiting for me, and they are getting impatient, I think. But I'm gonna have to put my noggin onto how to solve this better, because I have a suspicion that this is just gonna be way too slow, managing way too much state. And I might just honestly go back, reach for Dijkstra's algorithm, because I'm pretty sure that's gonna be what we want here. Typical shortest path shenanigans. And by doing a formal Dijkstra's construction instead of this kind of half-created thing that I've got here, I think that will actually give me what I need. Because what Dijkstra's does is it keeps track of the entire path beginning to end, and that can then give me the information I need. The only issue I still will have is that of ambiguity. So it's going to be a modified Dijkstra's where one node can preempt another even if it's already seen it. So each node would need to keep track of not only what its predecessor is, but also and its distance. Okay, I need to keep track of the distance it was and the predecessor it has, and then a new node could come along and potentially preempt it by saying, "Hey, if we're the same distance, but I am a better predecessor than you, then I'm throwing you out and replacing you." I think it's reasonable because we know it can only happen in a rare occasion, and it'll always be at the leading edge of the graph, so we won't have any dependent nodes stretching out from the ones attached to the conflict that we need to go back and modify. It'll all be within bounds, I believe. So, I think I know what I'll need to do, but I'm going to do that later, I think, and cut it off for now. About, what, 2 hours in? Oh well. With that, I'll cut it off for today. This is going to be the first one I haven't completed in the allotted or the initial time, but I think that's okay. I'm going to lose a couple more next week because I'm going to be out driving, so might as well start slacking off now and slowing down a bit. I'll have a nice slow nice slow Saturday to figure this out, so I'll probably spend some time tomorrow hacking it out. Maybe I'll stream it, maybe I won't. But yeah, hope you've enjoyed me waffling through this horrendous graph walking code, and hopefully I can come up with something a little cleaner tomorrow, again with the proper Dijkstra construction. And with that, take care, enjoy Advent of Code. Hopefully someone else can solve this much more effectively than I can. I'm looking forward to seeing some of the solutions coming out of this one. And keep learning languages, especially Clojure.